Okay, so online people, we just watched this exciting video that is linked in your PowerPoints. And Brody was saying it's his favorite video ever, and it's now going to be his ringtone. Okay, so this is where we're at today. You have a quiz. It's open until tonight. We'll get out early. You can take it. Please take it. Please take it. Oh my goodness. You guys have done great. And you've been doing great on masks, and I owe you cookies. I'm going to write this down for Tuesday. But yeah, freshman class, it's the same deal. They're like, okay, on Friday, you'll get out a few minutes early. You can go take your quiz. It's open till tonight. And so many people just did it. And then they're like, right, I was supposed to do that. I know. Please take it. Okay, we're going to look at the skeleton proper and then the axial skeleton. And you all saw this in class, in lab, right? Axial skeleton is kind of the long axis of your body. Yeah? And it's got three main parts. It's got your skull, your vertebrae, and then the thoracic cage. We did bones before. Now we're on to the skeleton. So it's the difference between the components and then basically we were looking at tissue before, osseous tissue. Now we're looking at the actual physical chunks. All right? This lecture, and I realize I'm being recorded right now. This lecture and the lecture when you learn the names of muscles of the body are the most boring lectures, at least in my opinion, of the entire semester. Because there's not a lot, so there's a lot to it, but the physiology is cool, but to just remember what things are called, just remember what things are called, okay? We're gonna go through it. You have now amongst you several skulls. If you have a skull, feel possessive, but also symbol it up and show it to your poor classmates who don't have it. When we get to the skull part, you're gonna be the following along, okay? Right. Okay. So the skeletal tissue, the skeletal system as a whole, it's gonna be bones. It's gonna be cartilage. It also counts as joints and the ligaments. I was way older than I should have been before I realized that joints were called that because they join bones. It just did not occur to me, and I was like, oh, yes, that's why, right? Yeah. So it's mostly bone. It's a little bit of cartilage. Ligaments are going to be connecting bones and reinforcing joints. There's a whole chapter in your book on joints, really important. We'll see that next semester for A and P2, because we have to get through some stuff. Skeleton's heavy. If you want to judge about how much yours is, the quick and easy way to do it is to figure out 20% of your body mass. So if you weigh 100 pounds, it's 20 pounds, right? If you weigh 120 pounds, then it's going to be 24 pounds? This thing's heavy. It's a lot of you. Two major divisions. Axial with long axis. What's this appendicular? All the appendages, right? Everything that sticks on to you. That's Tuesday's exciting, dramatic topic. Today we're looking at the axial skeleton. 80 bones, 3 big regions. The point of it is basic, okay, so probably obvious, I hope obvious. It's going to be the long axis of your body. It's going to support your head, it's going to support your neck, it's going to be there. And it's enclosing a bunch of your squishy, important organs, right? So things like your brain, it's going to provide this nice case for it. It helps protect your spinal cord, also hugely important. Your rib cage is there, helping protect your heart and other things. We're cool with this? Here we have it in our little skeletal guy in blue. axial skeleton. Everything that's not blue, or green, whatever, blue. Okay. Everything else is appendicular, right? It's nice long axis of your body. Okay. So from here now, this is where you follow along with your thing, and feel free to show your neighbors. Is everybody at least one person away from somebody with a skull? Yeah? Okay. The skull has two sets of bones. It's got cranial bones and facial bones. Oh, I was going to ask questions. Oh, that's lots of questions. Cranial bones are going to be protecting the brain, mostly. They'll also attach head and neck muscles. And then facial bones are going to be, form the basis of your face. They've got holes they've got all sorts of holes. Help me out, what holes? Somebody point to a hole and tell us what it's for. Yeah! You don't want this to be solid, right? You can have your eyeballs there, another hole. Somebody has a skull. And feel free to pick an obvious one. Oh, yeah! Say what? Ears, right? Okay, we have lots of holes to let things in and out, but it's still mostly a case. It's also going to secure your teeth, right? These facial bones. And facial bones, as you're looking at the skull, and I realize I don't have enough for everybody to have one by themselves, you see all sorts of weird bumps on the front, right? It's not flat. There's going to be tons of sites of attachment for facial muscles, right? Yeah. And most of the skull bones are locked really, really tightly together. One exception. What's the exception? Jake totally knows. Say what? Yeah, this one's adjustable, right? It's attached, like it doesn't fall off. But it's not sutured in place. Oh, if you ever want to watch Robin get somewhat agitated, to talk to him about snakes dislocating their jaws. Has anybody ever done this? Oh, snakes don't actually dislocate their jaws, and he feels deeply about his life mission to help people not think this. Anyways. The joints are called sutures in the skull. Ari, can you hold it up and point one out to the class? Yeah, you can see on your skulls, and people, I realize, I'm sure you know, but like the ones that are color coded, and mostly I gave color code to ones people up to show them a long ways. The skull's not actually color coded, right? Okay. The sutures they're officially joints, right? They're just really, really tight. Oh, here we go. Oh, other things. While I have you, have you ever seen so like a newborn baby, like a fresh, they're like 2 days old? What shape is their head? It's like weirdly long and kind of pointy, right? Sorry, and try not to make you feel freaked out. It's kind of pointy. Babies' skulls are adjustable. I mean, like don't like squeeze, but like as they come through the birth canal, they're not all their bones have fused, and their skull squishes a little bit. Just in a couple days, it goes back to being kind of normal. But for you, your bones have solidified. I don't know if you caught it in the exciting, dramatic YouTube video. It legitimately says it's made for kids. There's a whole one, too, about the lymphatic system I was watching because I make poor choices with my life. I'm trying to figure out what kind of parents like, hi, 5-year-old, learn about the lymphatic system. I don't know. I have no idea who this person is. Anyways. I don't know. Did your parents do these kind of things to you? No? Okay, that's probably why you're, like, turning out so nicely. Where was I going with this? All right. In the thing, it got all excited about how babies have more bones right? Do they just like lose chunks later? Babies have about 300 something, and you have like 206. What happened to the extra bones? They just join together, okay? They come together. Yeah. Okay, so here we are with the skull. We're gonna learn together. We're gonna learn the bones of the cranium and the facial bones. Does that distinction make sense? They're both bones of the skull, but face and cranium. All right, so facial bone is basically the front part, the anterior aspect. Cranium's divided into a vault and a base, so basically the bumpy part and then the bottom part. The brain is chilling inside what's called the cranial cavity. Most of your skulls open up if you want to open it up and like look and see where the brain sits. That is a good thing to do. Yeah. Your buddies can see it. Anybody who's holding brain, make sure your buddies can like, you okay? Sneeze? Oh. No, it's good. Sorry, just. Okay. So here, this is if you can't see it so nicely. You've got the brain sitting in there, right? Yeah. I'm not going to make you watch it, but it's in your notes in case you want to. The same people who did the skeleton one have one just about the skull. We're not watching. I'm not nasty. I just. If you're like, oh, but I like this, on your own time, you can watch it. Put it on loop. Okay, so the cranium has this cranial cavity, but also some other holes to it. Probably noticed them. I need a stick. I have a stick. It's got the orbit up there for your eyes. You've got your oral cavity, right? You've got a bunch of holes there in the front. Pointed out, you have internal ear cavities, the nasal cavity for your nose, right? Orbits, where the eyeballs live, they're called orbits. The skull has 85 different named openings. Go ahead and look at your skulls. There are a lot of little tiny ones. There's no obvious big ones. There are lots of little tiny ones. We're not worried about all of them, but there are, if you're motivated, 85 different ones. We're talking places for blood vessels, places for cranial nerves, there's a place for the spinal cord, tons of holes. I know, right? Yeah. Okay, cranium. Is this too fast? Are we okay? If anybody has any genius suggestions for getting through this without just blabbing, let me know, because it's just names. It's just names, like, all day. Cranium's got 8 cranial bones. Frontal bone, the parietal bones, occipital lobes, temporal lobes, sphenoid bone, and ethmoid bone. The parietal bones and temporal bones are paired. And this is the part fall along with your skulls or with your face and head. Okay? Frontal bone. Anybody can they find it here? Which one are we looking for? Yeah, everyone's like, yep, right? That one, the naming's pretty clear, right? It's there, it's up in yellow right there. It's holding a bunch of the face. It's got the forehead is part of this. It also, you'll see it's part of the cranium, but it does go all the way to like the eyebrows. So it is on your face, but it counts as part of the cranium because it's big and it's large and it's carrying a lot of that front part of your skull. All right, you can see it's coming down to where the nose is. Yeah, it's forming part of the orbits, right? So the top part of your eyes. It's going to have a bunch of holes in it to let nerves and blood vessels through. That's about it. We're okay with where it's at. If you recognize this one, frontal bone. When we get to the brain, in either what's convenient or sloppy, the lobes of the brain are named after the skull bones that are on top of them. So the frontal lobe is right under the frontal bone. And then you have parietal lobes and temporal lobes and, the whole bit. Okay. Oh, and here we're looking at frontal bone again, but now we're looking at it cut open looking down. You see that okay right there? And if you want to look at not color-coded, right there. The next one, if you look at your skulls, so the frontal bone's really big. Look at the cranium. Where's another big chunk? It's probably, yeah, I already found it. It's probably easiest in the color-coded ones. Do I hold it up and show people? Yeah, that blue, they're paired, right? There's a suture down the middle of it. Yeah. Paired, those are the parietal bones. They're basically this part of your head. All right? It doesn't go all the way back, but it's the top part of your head. It's the part that if, I don't know, something drops in your head, that's probably where you're getting hit. Here we have it in just regular picture with all the labels. I don't know which labels to take off. I just want to put them all on, or leave them all on. Frontal bone, parietal bone. The skull, this is probably obvious to you, maybe, but just bears mentioning. The skull sticks out in the back. I hope you know this. But like, when people draw pictures or like drawing people's faces, usually what they forget is that there's a lot going on behind it. They draw basically a little circle. Basically they have the face flat. There's a lot going on behind you. Also, I should have brought string or tape. Also, your head is very big. Not like you personally. I mean, yes, you. Humans' heads are very big. Does anybody want to take a guess of how many times you could go around your head before it equals your body length? 1, 2, 10, 50, 100? 3? Anybody would think that number's too small? Think that number's too big? You should find out. No, it's good guess. Somebody should try it and then report back to the class. Yeah. I'll come with string. If nobody does, I'll come with string one of these days. All I'll say, your head is very big. Okay, now we're on to the occipital bone. Everyone's okay with where this one is? We're looking here at the very back. Yeah. In cartoons, I have no idea what they do with cartoons now, but with cartoons, have you ever seen, like, in a comic, a character gets hit in the back of the head and then they see stars? Yeah, have you seen this? Yeah. Okay, great. Sometimes I have these references that people are like, nope. Okay, but you've seen this, right? The reason for that is the visual areas of the brain are right underneath the occipital lobe, and legitimately, if you get hit in the back of the head, you will see stuff that isn't there. You'll see splashes flashes of light, spots. But yeah, occipital bone's right there in the back. There's also a really, really big hole in the bottom there. What's coming out of that big hole? Say what? I heard it. Yeah, the spinal cord. Yeah, it's really, really good. It's called the foramen magnum. Magnum meaning big hole. So it's the big hole that your spinal cord comes out. Great. Oh, also is everybody comfortable with bones articulate with each other when they touch each other? Okay, it can be articulation even if there's like a little bit of cartilage in there, or if there's just a suture, but they articulate with each other if they're touching it. It's what bones they border. Okay, so here's our picture again. We're right here looking at occipital bone. Okay. Temporal bones are a weird, funky shape. They're right here. Hopefully you can follow along with them. Once a skeleton has, skin and stuff on, what's in that general location? Yeah? Say it loud. Your ears, right? Excellent. I'm going the wrong way. Am I going the wrong way? No, I'm going the right way. I put the same picture in like 14 times because it's helpful to see it. This right here is temporal bone. See it right here. We do the temporal bone right here. This little sticky out bit is called the zygomatic process. Can somebody who has it, can they hold it up and point to where that is? Yeah. Right. Okay. The mastoid process has a bunch of little holes, little sinuses. It's great. I need to turn my page. I need to turn my pages. Okay, yes. Here we are. Up here, well, you're right up here. This is basically your, well, we'll get to that later. You got ears. It's great to have your ears right there. They're amazing. They're wonderful. You need to have a hole. You need to have a hole for them, and with having these little cavities, it's supposed to be helpful for resonance, and your hearing can be pretty good, and life's great. This is wonderful. The problem is, your ears can get infected often. Like, they're a hole, they're open to the outside, they're warm, things can live there, right? You can get infections there. The problem that becomes scary with this is that a middle ear infection can jump up to the mastoid process area pretty easily because it's kind of porous. And those mastoid air cells are really close to the brain. There's a tiny bit of bone between them and the brain, but not that much. And so it can happen is infections can jump to the brain. And so your brain tries really hard to keep infectious agents out, but going in through the ears is one way it can happen. Yeah. We're okay with that? Okay. This next little guy, you'll see it best if you take the lid off your skull and look on in. Cephaloi bone, it looks kind of like a bat. It looks like that. This bone touches all the other cranial bones, right? So it touches the frontal bone, it touches the parietal bone, it touches the temporal bones. It's this weird, funky shape. It touches everything. It even goes back and touches the occipital bone. Like, it's everywhere. The important things for us to notice about this is it has the pituitary gland. Well, it houses the pituitary gland. Like, you can't see it right now, but it's in there. That's about it. It's cool. It's there in the middle. It's not paired. It's just one of it. I'm pretty sure Descartes thought that, if I recall, Descartes was convinced the pituitary was the seat of the soul because it's nicely there in the center. There's actually no evidence that that's what houses the soul, but it's cool. That's there in the middle. Fair enough? Alright, and yes, old anatomy books say this is bat-shaped. I personally see moth more. Anybody have another suggestion for shape of this thing? Yeah, okay. The ethmoid bone is deep in the skull. can you all find it? It's probably easier to see. It's tricky to see either looking front or looking inside, but inside's probably a little bit easier to see it. It's basically making the roof of your nose. It's making part of your orbits. That's what it's doing. It's got what are called the cribriform plates. So from your nose, you're gonna have nerves going up into your brain. So you've got little holes that are gonna let those nerve fibers up into your brain, right? I think this might have been with Comfort. I can't remember what I told people at Comfort, but people who you might actually know somebody who this has happened to. If you got head trauma, or say you're playing football, sorry, I cannot. Football causes me stress just because of the clunky aspect of it. But if someone's skull gets hit really hard, what can happen is it can shear. So you've got the nerves going up through the cribriform plate, and you move really hard and it can shear those nerves off. And so people will often lose their sense of smell that way. Yeah. It's rough. Okay. Everyone's doing okay? Cranial bones. This one's called what? Frontal. Way in the back? Sides? Yeah. Down by your ears? Cool. Sounds like people know what's going on. Okay, now we're moving on to the face. So you're like, I've got this. Old news. Okay. We're now onto the facial bones. So 14 bones. 12 of them are paired. So we've got these ones we're gonna go through one at a time. Help me out though. Did we just already see something that had a zygomatic process? Are we okay to have it again? Can somebody hold up their skull and show us maybe where that's gonna be? Yeah, okay, different bone, but the same general location. Anatomists get lazy sometimes with names. Okay, the big one you probably know. Does anybody know what this jaw bone is called? Oh, yep. Genius. This one's adjustable. It's also the strongest jaw in your face. Has anybody ever seen, I don't know if I should show you more YouTube videos. Has anybody ever seen, like, people holding on to something? It's like a fair trick or a circus trick. Holding on to something and being, like, raised up by holding on with their jaw. You ever seen this? You're about to. Because I bore myself sometimes. I don't know what this means. I'm actually going to freeze this just to make sure I don't show you something inappropriate at first. Sure, this should work. I hope. Let's find where. Great. Apparently it's 93 years old. Ah! Drat! Okay. Unfrozen? Thanks.
Ladies and gentlemen, we are in the streets of New York City, where we are about to watch a 93-year-old man pull a car across this finish line. Mike, are you ready to do this? I'm as ready as I'll ever be. Now, the idea is that the front of the car has to cross the finish line, correct? That's right. The front tires have to cross it. So that means you have to go all the way up there. That's right. Good luck, Mike! God.
Okay, commercial break. Okay, moving on.
My name is Mike Greenstein.
Fine,
How old
get
are
to the
you?
point.
Oh my God. Go, Mike, go! 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 Moving.
Yay! Yay, happiness. Just so you know, you might have this talent too. You probably have never tried, but you could if you need a new hobby. How do you find out if you're good at that? Right? You're like, I know, right? Okay. Thank you for indulging me. It's a strong bone. Also, like, you can bite really hard. It's very strong, and also you can get a lot of force in this chomp. Yeah. Okay. So they've got mandible. The sticky up parts. One is called a ramus, two rami, and we're good to go. Okay. Oh, online people, we watched America's Got Talent 93-year-old Pearl's car with teeth or face or something. Okay, the next bone we're looking at, we have the jaw right here with the mandible. We also have an upper jaw, right? That one's fused. That one's called the maxillary bones. Well, there's two of them, but maxillary bones. They're, with your skull, there's this top part, and it's also moving up towards the nose. All right? Mandible, maxillary above it. I realize I have a mask, so I don't know why I'm pointing to my face. It's up there. Zygomatic are your cheekbones. It's going to articulate with the zygomatic process of like the temporal bone, right? So it's gonna touch there. Cheekbone is also the bottom part of your orbits, right? There are so many. I should actually count them. There are so many bones that make part of the orbit, right? Like coming from all directions. But zygomatic bones up there. So far, so good. Great. Nasal bones. I realize we've seen lots and lots of bones that do touch the nose. They're. I need my stick. I don't need a stick for this. Okay. They're right here. They're forming the bridge of your nose. If someone says their nose is broken, that's what they're talking about typically. Lacrimal bones. Does anybody know what if you talk about, like, I know this. Okay. Lacrimal has to do with tears. Is this, I'm not sure if this is like common knowledge or not. Is this? I have no idea now what people know. Okay. Lacrimal bones, they're right here in green. They're hard to probably see on your skulls. You can probably find them. So you've got your nasal bones. You'll see your zygomatic bones come up, and then like kind of behind it to the side a little bit, forming that part of your skull. You've got lacrimal bones. They're called this because they've got it's where your tears get to drain. So that's convenient. Is everybody seeing? If you're not seeing a skull and you want to, shout at your neighbor. Comfortable with this? People are doing a really good job of sharing stuff. Okay. Palatine bones involved with the palate. We have it here. Sorry, I need to all the people. We've got the vomer. It's this little dinky one that is part of the nose. So are people comfortable with where we're looking? Like, probably easier upside down? Yeah. So far, so good. I realize you're just going, this one is nearly impossible to see from the outside. This cut is looking inside. Are we okay with where that's looking? Forming the lateral walls of the nasal cavity. All right. Did I ask anything? The hyoid bone isn't part of the skull, but I don't know where to put it because we're not going to talk about it when we see the appendicular skeleton. It's not bone of the skull. It's not a bone of the spinal column. It's not part of the limbs. It's just kind of there. It's the only bone in the body that doesn't actually articulate with any other bone. It's chilling right there. It's the base for the tongue. So you need someplace to attach to the tongue, but you need it to be adjustable. And it also has a bunch of muscles attached to it that are important for like speech and swallowing. It's there. It's kind of the like base that everything holds on, the thing for swallowing and speech holds on to, and it's just right there. And it's a weird bone because it's not articulating with any other bones. We're good? So that hopefully has got us now through cranial bones, facial bones, hyoid bones, just because why not? People okay with new topic? Whew, great. Vertebral column goes from skull to pelvis. You can call it the spine, you can call it the spinal column. It's nice, it's strong. It's gonna act as a support, right? So the weight of your, it's gonna help hold you up, right? It's gonna be able to transport this weight to other parts of you. It's also gonna be a place that muscles can attach to, which is helpful. It's also going to enclose the spinal cord, which is really, really important. The spinal cord is amazing, it's super important. It's very delicate. You want it encased in bone. You also have, let's see. It's curved. Spinal column's curved. And it's actually double curved. So it's double curved like this. You have a bit of a curve here, a bit of a curve there. Actually, okay, if we want to count, it's got four officially named curves. Okay. Cervical region's up here, right? But you'd probably just call it your neck. Next, we've got the thoracic, the thorax, right? The like middle part of you. It's this high part. There's 12 of them. Lumbar is down low. People talk about like, oh, lumbar support. I don't know if you get with old people who aren't pulling cars with their teeth, they talk about lumbar support. All right, lower back. We've got sacrum, which is basically where you think the hips are, and then the coccyx, which is the very, very end of the column. If you're interested in remembering these, my helpful mnemonic is meal times. You want to eat breakfast at 7, the first one, lunch at about noon, there's 12 here, and then supper about 5. I mean, maybe not, that's not maybe when you eat, but the number's there. Sacrum's just one bone. They've been fused together. Coccyx also has been a bunch fused together. Questions about this? We're okay? The point of these curves is, well, it's going to help give the whole system a tiny bit of give, and you've got more flexibility this way. If you just have a like ramrod straight, you don't have much give to it. You've got I know, don't memorize this. I just need to show it to you. We'll talk about it with joints, but it's worth noticing. You've got all these individual bones, but you have ligaments that are going to help support this, right? So when you put it together in lab, you put all these little vertebrae together as a line, but if you were to bend them, they'd pop out. You want ligaments there, you don't want them to pop out. Anybody know what it's called if they pop out at all? Just a little bit? It's not really supposed to happen. But yeah, it's a bad deal. Okay. How much oomph do you guys have? A lot, or is it like it's Thursday hard day? We doing okay? Okay, I'll keep going then. Yapping about stuff. Bunches of ligaments. It's gonna help make so that you don't when you bend over, you don't want to hyperextend or hyperflex. You've got ligaments that are going to constrain how much movement you can actually do, which seems restrictive, but it's helpful because then you don't break things, right? Just to see this, don't memorize it. Do you see this little glob here? You've got these little pads. They're called intervertebral discs. They're basically shock absorbers. They're made of goo, basically collagen, fiber cartilage, and they act as shock absorbers the whole way down. These curves you've got here, sometimes this can get messed up. Sometimes people's spines can be in the wrong position. Anybody know conditions where people where something's wrong with how people are bending? Scoliosis, yeah. We'll see a picture of that. Scoliosis is a big one. What is it? Like, how are people bent wrong?
It's like moving to the side.
Yeah, and this is a problem. It can, sometimes it hurts with breathing. It makes it harder to breathe because things are pushing wrong. Yeah, scoliosis is a big one. Any other condition or thing that makes people's spine curve oddly?
Isn't there one that starts with a K?
Yeah, there's one that starts with a K where people are hunched over.
Yeah.
Yeah, we'll see that. And then, have you all seen pregnant women walk? They do that thing, right? Those are the three main ones, right? You could either be curved too far like this, you can be curved sideways like scoliosis, or you can be curved out. They all have names. Scoliosis, lateral, kyphosis, hunchback, is where hunches over, and lordosis is where it's called swayback. You'll see it in pregnant women. You'll also see it in people who have pot bellies. Sometimes. Those are the three situations. Yeah? Questions or concerns about this? Each of them are coming for a different reason, right? This one usually, there's some anatomical issues here. This one typically is going to be something like osteoporosis, where it just bones have been broken and crunched up. Lordosis is interesting because, yes, it's abnormal curvature, but it actually makes sense why it's happening, right? So if someone's pregnant, they're walking like this to support things better, right? You do it too if you've ever carried a really, really heavy box and you're holding it like this. You push out. If you do it too long and too much, you can hurt things, right? But you're doing it just because it's how you balance better. But it can get dramatic to the point that it's a problem. Concerns about that? The vertebrae all look kind of similar. We're going to look at, so vertebral column, the whole thing, each individual vertebrae kind of look the same. They've got several parts. They've got this body here. Sorry, I should show it to the online people. They've got this body here, right? And then they have what are called spines that stick out. You've got this central vertebral canal. It's going to be great. Yeah, I don't know what else to say about things. you've got a vertebrae, it's got spines, it's got this major weight-bearing portion, and you're gonna let nerves out through the edges, and you're gonna let spinal cord down through the middle. Fair enough? Sweet. So those are the actual vertebrae that aren't fused, right? Once you go down to the sacral region, they fuse together like this. You can kind of see how they used to be separate, but they fused. Coccyx has a similar deal. It used to be separate, used to be 4 little tiny ones, but fused together here. When you guys saw the pelvises in lab, you saw the coccyx sticks out. Anybody notice any differences between the male and female pelvises on how that stuck out? I realized it was ages ago.
The male one was more like curved, female one was a little, like it's more round.
Yeah. Sticks farther out and then is pulled back in females. Yep. Okay, so that's the spinal column we have. The last portion, and we're gonna go through this fast because I want to get you out early to do your quiz, though again you have until tonight, is the thoracic cage. It's basically the sternum and the ribs. It's part support, it's gonna help, it's gonna be great, protect vital organs, provide places for things to attach to. We've got the sternum right here. We've got ribs right here. I realize in lab you probably did look at true ribs, false ribs, and then these floating ribs. But we're going to look at the sternum first, which is this part right here. People will sometimes call it the breastbone, right? 3 fused bones, nice and flat. The xiphoid process is this little bit on the very end. For some people, it points back. For everybody, it's there at the bottom. For some people, it points back. And amongst other reasons, one thing that can be a problem. I need to tell you good things. Just the fact that usually your body functions really, really well. Like, usually things are going great. Just the problems are dramatic, so I like to talk about them. For some people, the xiphoid process pushes posteriorly more than normal. And the reason, amongst others, is not to get hit in the chest is that can go back and poke underlying organs. So it can hit the heart, it can hit the liver, and people can it can cause some massive hemorrhaging. So don't throw bowling balls at people's chests. This is bad. Yeah. So that's the sternum. Ribs, you've got there are some variations, but people typically have 12 pairs. You've got what are called true ribs, the first about 7. They're gonna go and directly touch the sternum. I mean, there's cartilage involved, but they're gonna go up and directly touch the sternum. False ribs have a ways to go to get there. Wrong way. They've got they join the cartilage above them, and then the floating ribs don't attach to the sternum at all. Alright? And there is some variation in number. There's not a distinct men have 12 pairs, women have 27 or something. Men and women both typically have 12 pairs. Sometimes people can have extra ones, sometimes people can be missing some. Questions about that? That was really fast, I realized, but that's actually about right. Concerns? Everyone sold on taking quizzes? You can leave your skulls on your seats, and I will go pick them up.